Okay, welcome to ELM260 Industrial Robotics. I'm going to give you a little brief overview of robotics, and before we get into the specifics of the robots we're going to be using. So to start off with, I just thought I'd show you a couple of videos of robots doing actual work. Um, so this first one here is a video of robots who are that are painting cars. And one of the largest uses of robots is in the automotive industry. They were one of the first industries to employ robots on a regular basis. And so they really are the workhorses of industries like that. So what you see here is two robots in a big painting booth. And if you notice, they almost look kind of human the way they move. And the reason for that is these robots were actually programmed by having an actual expert painter move them through their paces once and then record the movements of the painter. So there's actually a human input on that level. And then once they learn how to do that particular model of a vehicle, they just, the manufacturing process, whoever's in charge or whatever, they just hit go and the robots will duplicate the same path. So anyway, that's one. I'm not going to show you the whole video. If you want, I'm going to put these links into the comments below, so you'll be able to check them out if you want to. And there's plenty more out there as well. Okay, the next one here is another example of a painting robot. In this case, it's painting cabinetry, doors, windows, and
My business
wooden
is a custom
panels.
painting business. We specialise in.
So again, another same type of robot, painting robot, but in this case, just a different application. You wouldn't think necessarily of a woodworking company as using robots, but that is certainly one of the possible uses. So you can see it's a similar kind of thing where an expert painter went through the initial movements, and then when the robot program is run, it follows the actual movements of the painter. It actually remembers where exactly it moved. So here's another example, another use of robots that's pretty common is welding. It's one of those things where a robot can get very consistent welds from one to the next. It can sometimes be a dangerous environment, and so the robots essentially take out some of the variables of human error. And what you're seeing here is robots welding together some kind of a chassis, some pieces of again, some sort of a vehicle. I guess this is a BMW video from BMW. So just show this welding robot come down and complete a seam. All right. The next one here is an application that's becoming more common. When you want to make a very precise cut on a piece of material, probably the best tool to use is a laser. Lasers can be controlled very precisely. And when you combine a laser with a robotic arm, you end up with a machine that can make extremely precise and intricate cuts and go around corners and make contours. There's a company in Oxford, and they also have a plant in Westboro. Sorry, no, not Westboro, Marlboro, called IPG Photonics, and they do this kind of, they make the lasers, and they also do a lot of development with robotic arms and the kinds of applications you see here. All right, so there's another one. And I just threw a couple in here, videos of robots just being programmed to just do something really cool that doesn't accomplish anything, but just demonstrates the capabilities. So this is an interesting demo that was put together by ABB Robotics, where they have two robots working together. And so one robot is holding, you can see these cans on a tray. The cans are actually glued to the tray. They're not just balanced there. But anyway, and the other robot's job is to thread this pointer between the cans. Now what you notice is as the one of the robots moves, the other one moves its reference point so that it can keep up with the movements of the original robot. We're going to learn a lot in the course about these things called frames. A frame is a coordinate system, like an XYZ coordinate system. And anytime you have a coordinate system, you have an origin to the frame, and then you can take a frame and tip it up, and make so the x-axis goes up at an angle and the y-axis goes up or down. And so what's happening here is the frame, the XYZ coordinate frame for the robot with the pointer is based on the position of the robot holding the cans. So as those cans are moved, the XYZ position, the reference point is moving, and the second robot moves in response to it. So you can see how it's stationary here, and it just tracks wherever that first robot goes. So it's a really interesting application showing some pretty cool capabilities of robots. All right. And the last one here is from FANUC robots, which is the kind of robots we're going to be using in the lab, are FANUC robots. And this is their largest robot. It's claims to be the world's strongest robot, and I have no reason to think that's not a true claim. So it's the M2000IA. The ones that we have in the lab are the LR-Mate 200ID. It's much smaller, obviously, but these robots are in very different sizes. So this is the world's strongest robot, picking up, it says it's a 1,200 kilogram. That's, how many pounds is that? It's about, I don't know, 2.2 kilograms. So that's more than a ton. So whatever this thing is, I'm not sure what it is. It's picking up, looks like a big, I don't know, engine block or something. Maybe it couldn't be that, but anyway, it's something huge and heavy. So this robot is housed in a warehouse with a very high ceiling, and you can see it uses hydraulics to create the force to be able to lift this huge object. Okay, so there's some examples of robots doing what they do. A little bit of background on robots. From the early 1940s was around when the term was coined, and the original implication was more like a science fiction type of definition, implying a mobile machine that had a human form to it. There were science fiction movies made, many years ago, and so that was one of the original meanings. Actual industrial robots started to come out in the 1970s, and the thing that made the industrial robot a reality and a possible reality was that the microprocessor was developed around the same time, and the microprocessor allowed this very fast computation of numbers. Essentially, the robot is a big computation machine. It's adjusting its position based on the coordinate values that it is trying to map to, and so that there's a tremendous amount of data that has to be processed to keep the robot doing its path consistently. Anyway, a couple other definitions. Webster's Dictionary: an automatic device that performs functions normally ascribed to humans, or a machine in the form of the human. That's more like the science fiction type definition. And then the Robotic Industries Association has a different, more technical definition, that it's a reprogrammable, multifunctional machine designed to manipulate materials, parts, tools, or specialized devices through variable program motions for the performance of a variety of tasks. So the key here is that it's reprogrammable. You can program it to do many different things. It's also multifunctional. Depending on what you put on the end of the robot, you can have it grab things, pick them up, You can have it do welding, you can do painting. So very, very versatile machine. And so robots have been making their way into everyday life. Down at the bottom, you see the Roomba, the vacuum system that just creeps around the house and automatically vacuums while the owner's not home or at night or whenever. There's a lawn cutting version of it, similar idea. And these devices are able to tell when their batteries are getting low, and they can track all the way back to the charging station, plug themselves in, get recharged, and go back out. So they're fully autonomous. The one in the upper right is getting closer to a humanoid type robot. They're being used as service robots now in various situations, sometimes hospital situations or even people's homes. It's a bit expensive at this point, but that may be something that we'll see more and more of. You'll also see robots used in medicine. This person over here on the left is a surgeon, and this robot it's got all these different instruments that are inserted into this patient. Um, they're doing very often surgery requires extremely fine movements, and so what this robot does is actually the surgeon is controlling the movements, but the actual movements are maybe 10 times smaller than the surgeon's movements. So the surgeon can make larger movements and get very, very precise movements to do tiny, tiny stitches and things like that. So seeing it into the medical field as well.